Hi everyone, this is the Math Nexus, and we are in the second lecture for IGCSE and O-Level Advanced. So the main objective of this specific lecture is to solve exercise 1.2, which revolves around what functions are. Okay, so what are functions? A function is actually a rule which maps each x value, meaning a input, to just one y value, meaning an output. Okay, to clarify this, we are told that for one input we get in the form of x, we get one output in the form of y. Okay, so which means that one many mapping would not be applicable here because, for example, we take a mapping which says x is mapped to plus minus under root x. So this will not be a function because for one input value, it is giving out two output values in the form of plus under root, a positive under root x and negative under root x. So this is not a function. Function is any rule or mapping which gives out one output for whatever inputs you given. Okay, so there are two basic forms in which functions can be written as. One is given here. Both are given here actually. So f x is mapped to x plus 1. This is the one form of function you can write, and f x function of x is equals to x plus 1, and this is the second form. So basically what it read is that the function of f is such that this input or any input or x itself is mapped to x plus 1. So if we just input the function of x, we get an output in the form of x plus 1. Okay, so we know the two forms in which it is written, and specifically I want to tell that it's not important that we use fx to be a function. It can be gx, it can be hx, kx, ax. I mean, any alphabet that you can think of can be a function. You just have to define it to clarify it. Okay, so now we should understand that what a domain and what a range is. Well, I think that this mapping diagram would be similar to you if you have done exercise 1.1, and we learned that this first type of oval is called an input, in which we give values 1, 2, 3, and the other set is an output in which we get 2, 3, and 4 after it passes through a function or a mapping which is x is mapped to x plus 1 or any other specific rule you can define. So now we are more similarly, we are going to say that the input we give in a function is called a domain. Okay, it's called a domain, and the output we get is called the range, and many people may also call it the image set. This is because, well, we are getting the image after of input after it's going through a function. That's why it's called an image. But it is better to be familiar with these two, domain and range, as these mostly come in the papers. Okay, so if you just see here, the first question we are asked is which of the mappings in exercise 1.1 are functions? So if we had a clear understanding of the intro I gave, we should know that functions are only mappings which give out one input. So any mapping which is like one many mapping will not be a function. Otherwise, everything will be a function. So from the previous exercise, if we have solved it, we get to know that the question number 1 was a 1-1 mapping. So that means it was actually a function. So we are just going to give the answer in the form of yes or no. So yeah, the first one was a yes, and the second one was a many-one mapping. So again, one output. So it's going to be a yes. It's a function. So I'll just label it number 1, number 2, and the third one, we know that the third one was a 1-1, meaning one output. So again, this is a function. Yes, it is a function. So the fourth one was a 1-1 mapping again. So again, it was a function. Yes, it was. The fifth one was a 1-1 mapping again. So one output, meaning it's a function. The sixth one, another 1-1 function, another 1-1 mapping, again, one output, meaning this is a function. The seventh one was a 1-1 again. Book is full of 1-1s. So again, it is a yes for us. And question number 8 was a one-many type of mapping. That means for one input, we are getting two different outputs. So this won't be a function. So at last, we are getting that no, this is not a function. On to question number 2. And if we see here, we are asked that find the range of each of these following functions. So as we discussed earlier, the inputs we give are called the domain, and the outputs we get after they follow a specific rule is called the image or the range of the function. So for question number 2a, we are giving the function f(x) is equals to x minus 5 for x is greater than or equals to -2 and or lesser than equals to positive 7. So this is a easy question because now for the range we are just going to input the minimum value f -2 instead of x, of course, because we are taking the minimum value to be -2, and -2 minus 5 is equals to -7. So what did I do here? I said the function of x is equals to x minus 5. So that means if I input the value of x into the function, I will get x minus 5. Similarly, if I just replace -2, I put the value of -2 in my function, I get the result. Instead of x, I will be writing -2 minus 5 as the function said. So that will be equal to -7. And again, we will now add the most highest value we have of x. So it will be 7. So if we just input the value of x to be 7 in the function, we get 7 minus 5, which will be equals to 2. So now if we just set it up, we are going to see which is the most minimum value. We are going to just write the function of x, and we are going to say that it is greater than equals to -7, but it is smaller than and equals to 2. So this will be the image of this function. That means from -2 to 7, we are going to get the images of the values between -7 and 2. So if we just proceed, squiggly line. So on to question 2b. And if we see here, the function of x is equals to 3x plus 2. For the conditions, we are given that x is greater than equals to 0, but is lesser than equals to 5. So again, we are going to take the 2 minimum and the highest value. So if we just input the value of x to be 0, we are going to get 0, because 3 multiplied by 0 is equals to 0, plus 2, which will be positive 2. And similarly, if we just input the value of x to be 5, so we will get 3 multiplied by 5 plus 2, and 3 5s is equals to 15, and if we just add it by 2, we get the answer of 17. So again, we are going to see that which one of these is the lower value. And if you see here, 2 is the lower value and 17 is the higher value. So if we say fx is greater than equals to 2, but it is lesser than equals to 17. Again, let me give a small reminder that this is not the range of values for x. It is actually the image which x gives after it is input into a function. So these are what the question requires us. These are the image set or the range of x. Okay, and on to question number 2, C, sorry. And if we see here, we are given fx is equals to 7 minus 2x. And if we just draw a line here, like that, we are going to see that again the range of values we are given are -1 and 4. So again, inputting the lowest value, instead of we input the value of -1 instead of x, so we will get the function 7 minus 2 multiplied by -1. This will be equals to 7 plus 2 is equals to 9. It will become plus 2 because when 2 multiplied by -1, it will become -1, but 7 minus -2 will become positive 2. So that will give us 9. Again, if we just input the value of 4 instead of x, we'll get 7 minus 2 multiplied by 4 is equals to 7 minus 8, which is equals to 1. In fact, -1. So now again, if we just compare that which of these value is the lower value, you see that -1 is the lower value and 9 is the higher value. So again, fx is greater than equals to -1, but it is lower than and equals to 9. On to 2D. So we are given the function fx is equals to x squared. Again, another soft reminder that you can also write it in this form. Fx is mapped to x squared, and these two forms are actually the same, telling the same thing. So and we are given the range of values for -3 is and 3. So again, instead of x, we are going to input f3, which is equals to 3 squared, and which is 9, of course. And again, for -3, we are going to get 9. Now there's a twist in this. If we say that these two values are both the same values, so if we focus on part D, what may be the most minimum answer we may get after after we input the values between -3 and +3? So if we just say that from -3 to +3, we get 0 in between. Okay, that means that if we input the value of x to be 0, it is applicable here. So again, this is a kind of a use of your common knowledge and of course, if you practice a lot, you may know that what type of thing you want to hear. So again, if we just input the value 0 instead of x, we get the answer 0 square, which is equals to 0. So now if we see, the minimum value we get here is 0, and the most again, the highest value we are getting is 9. So we are going to say the function of x is greater than equals to 0 but is lesser than and equals to 9. Okay, let me erase. So on to question number 2, part E, and which tells us that fx is equals to 2 to the power of x, for the values of x are -3 and 3, I mean till 3. So again, if we input the most lowest value, we get f to the power of -3 is equals to 2 to the power of -3, which is equals to 0.125. On to f to the if we input the value of 3, so it will become 2 to the power 3, which is equals to 2 to the 4, 4 to the 8. Again, the most lowest value 0.125 and the highest value is equals to 8. So we are going to say that fx is greater than equals to 0.125, but it is lower than and equals to 8. So questions may arise that why did I choose the value of x to be 0 in this part D, and why not here? So the thing is that if we focus on part D, we see it's a squared value. So if we had input -3, we would get 9. If we had input -2, we had get 4. That means the negative value would not affected our final answer. That's why the most minimum value we can get in terms of x squared is from 0, because negative itself will not come after it is squared. So the most minimum value after the x is squared can be 0, nothing else. Negative values can't come. So that's why we wanted to focus on something which would give us 0. And obviously 0 came in the part of -3 to 3. That's it. So on to part F. Wait a second. So on to question number 2, part F, which tells us that fx is equals to 1 upon x, for which the range of values is 1 to 5. Again, we are going to input the value of x to be the most smallest value, which is equals to 1 upon 1, and obviously it's 1. The second value of f we are going to input is 5, which will give us 1 upon 5, which is the answer actually. But if you see the lower of these two values, it's not 1, it's 1 upon 5. Okay, so we are going to say the function of x is greater than equals to 1 upon 5, but it is lesser than equals to 1. So this is the image we get from it. And this is for question number 2. And let me go on to question number 3. Right. Yeah, research हो बोलोगे. Now we will proceed on to question number 3. And if you see here, we are asked to define now if we go on to question number 3, we are told that the function g(s) is x is equals to x squared plus 2, and x is greater than equals to 0. That means that we do not have any negative value in this case. Now we have to write the range of g. This is a different question than what we are used to, because we are given two values and then we find the range. However, as just one value is given, we are just going to input that single value. We are given that x is greater than equals to 0. So instead of x, we are just going to write g as 0 is equals to 0 squared plus 2, which is equals to 2. So now we have been given the image that for 0 we are going to get 2. Thus, what we are going to do is that we are going to say that gx, as this was the minimum image we can get, we are going to say that gx is greater than equals to 2. Okay, so that means that as we go on 1, 2, 3, 4, our image will increase according to the uh, input value, but it will not go lower than 2 because the applicable input values are only starting from 0 itself. That's why we are just going to say that gx is greater than equals to 2. On to question number 4. So if we see in this question, fx is equals to x squared minus 4, for x is a real number. Okay, now this in this question we are not given any limit. So what's the solution to this? The fact is that if you see here, we are given x squared in the equation. That means that whatever negative value we input for x, it's not going to affect the final output, the final image, or the final range itself. So that means that the minimum value we can get from x squared is if we just input 0. So that's why we are going to say that f0 is equals to 0 squared plus 4, which is equals to 4. And similarly, we will say that fx is greater than equals to, I'm sorry, this is not positive 4. Let me correct this. This is negative 4, and again this will be negative. So fx is greater than equals to negative 4. Now the thing is that why didn't I choose because this is a real, x can be any real number, so it can be from 1, 2, 3, on and on and on to infinity. But the fact is that the reason for me choosing the minimum value I could get was because we have defined that this is the minimum value, and then it's going to be greater than that, it's not going to be lesser than that. And if we want to find what it's gonna be less than, it's going to be really hard because it's actually impossible, because real numbers can mean any type of number as we go on. So that's why the minimum value we could get was 0, and the image of 0 is negative 4. So any image that will come after 0 or any other number will be greater than negative 4 itself. For example, I will just give an example. Sorry. So for an example, I'm just continuing question number 4, and we're going to say that this is for the explanation. If I just input negative 4, for example, f negative 4 is equals to negative 4 squared minus 4. Similarly, it will become 16 minus 4, which is equals to 12. So as you can see here, that 12 is quite a lot greater than negative 4. Thus, it is proved that the most minimum image we can get is from the input of 0. Okay, on to question number 5. We are told that the function of f is defined by fx is equals to x minus 1 whole square plus 5, for x is greater than equals to 1. Again, we are given the minimum, we are given the value of x for which it is greater than. So that means the minimum value of x is going to be 1. So the thing is that if you just define this to be, okay, 1 minus 1 whole squared plus 5, which is equals to 0 plus 5. And thus we are going to say this is 5. And we are going to say that fx is actually greater than and equals to 5. That means the image, if we input 1, will be 5. So now another question arises that why didn't we just choose any value that is greater than 1 itself? For example, 2, 3, 4, 5. And again, we get the same answer. We are going to say that what will be the value of x? Sorry, this is messed up. So, what may be the value of x for which this whole part of the equation will become 0 because it's going to be squared. The negative value will not affect the final answer. Fact is that if we just input 2 instead of 1 here, so it's going to be negative 1 squared. And I'll just give you an example. If we had input any other value, for example, even 2 instead of 1, we had gave 2 minus 1 squared plus 5, which would be equals to 1 plus 5, because again, this is going to be a positive 1. So is equals to, this will be, 6. Again, 6 is greater than 5. So this explains that the minimum value we can get out of this is when we input 1. So it basically is a test of your common sense. If you are practicing maths and you are familiar with these questions, you won't be confused when you counter them. Okay, now question number 6. What does it demand? It says that the function of f is defined by fx is equals to 2x plus 1 whole squared minus 5 for x is greater than equals to negative 1 upon 2. So again, this part of the equation is squared. So we need the possible values which may make it into 0. The thing is, if we concentrate here, we want in this part negative 1, so that negative plus 1 is equals to 0. And similarly, if we just input the value negative 1 upon 2, we are going to get negative 1. So it's actually, the answer is in the question itself. So if you find the range of the function f, we are going to say fx is equals to 2 multiplied by negative 1 upon 2 plus 1, this is whole squared, minus 5, which will be equals to 2, and 2 can be cancelled out, minus 1 plus 1 whole squared minus 5, which is equals to 0 minus 5, which is negative 5. So we are going to say the range of f in terms of x, if we say, is greater than equals to negative 5. So that's the answer. Okay, now just make a line here. So on to question number 7. And if we notice, we are asked that fx equals to 10 minus x minus 3 whole squared for x is greater than equals to 2 but lesser than equals to 7. And we have to find the range of f. So question number 7. Now what, again, don't be confused by this form of writing, because this is same as to write it fx is equals to 10 minus x minus 3 whole square. Okay, so now we have to find the range of f. Now if we concentrate in this type of question, we have to find out which value may give the most highest value of fx. I mean the most highest value. Okay, now the thing is that if we see here that this part of the equation is a square, and I told you that if you see a square, there is not going to be any negative value in its in the answer of that part of the equation. There is no negative value here, so that means that this is absolutely going to be subtracted from 10, the answer of this. So what may be the minimum value we may get from its answer? And that is obviously 0, because between 2 and 7 for the input of x we have a 3. Okay, that means if we just input the value of x to be 3, we are going to say f3 is equals to 10 minus 3 minus 3 whole square, which is equals to 10 minus 0, which in return is again equals to 10. So here we see that the maximum value we can get out of this function for the range of inputs we have is 10. So now if we just go on, what may be the minimum value of this function? The minimum value will only come when this is the most greatest. And where is it the most greatest? Obviously for the highest value, and which is 7. So if we just say the function of x and we input it the value of x to be 7, we are going to say that 10 minus 7 minus 3 whole squared is equals to 10 minus, what is 7 minus 3? It is 4, and 4 is a 16. So which is equals to minus 6. Okay, now we see again this is the most minimum value. And questions may arise that why do not we get the minimum value if we just input 2? Well, obviously, if we input 2, we are going to get the answer of 1 in this squared function. And if we just 10 minus 1, it's equals to 9. And 9 is obviously not lesser than negative 6. So that's the final answer, that f, the function of x, is greater than equals to negative 6, but it is lesser than equals to 10. Sorry, 10. So that's question number 7. And if we just let me raise. Okay, so on to question number 8. And what this question number 8 demands from us, it tells us that the function f is defined by fx equals to 3 plus x minus 2, which is in an under root, or x is greater than equals to 2. Find the range of f. So now again we want something that will make this value a 0, the under root value, because that's the main thing. That's where x lies, and the most of which we can get is when x, the value of this equation, this part of the equation, is equals to 0. So if we just say that fx is equals to 3 plus under root x plus 2, and if we just input f to be 2 in this case, we will get 3 plus under root, sorry, this is minus 2 here. Yeah, so we will get 2 minus 2, which will be equals to 3 plus under root 0. Under root 0 is equals to 0, and which is equals to 3 in return. So what we get that the most minimum value we can get of x is equals to 3, because any other value, because if we say we get 3 minus 2, you're going to get, I'll just give you an example. So the example is that if we just input any other value except from 2, we say that f4 in fact is equals to 3 plus under root 4 minus 2 is equals to 2. So 3 plus under root 2 is greater than 3. So this shows us that any value we get is surely to be greater than 3, except if we just input 2. So the input of 2 is will give us the most minimum image value. Okay, so we are going to say that fx is greater than equals to 3, and that's the answer. And that's all for today. Thank you. This is exercise 1.2, and I will be solving exercise 1.3 in my next lecture. Thank you.